Hello. In this video we want to further improve our application, our simple calculator. Right now, as you might remember, the calculator can handle only integer, so only variable which have a whole number. But of course we want also to sum maybe numbers with decimals, and for that reason we need to use a different variables that is not integer. So since integer data type can only handle whole numbers, we needed to use another data type which is more fit to purpose. Let's open Visual Studio and our simple calculator application. Here we go. Okay, let's see our application. Right now, if we scroll up our application, when we initialize our variables, first number and second number, as you can see, we are using integer. Integer represents a 32-bit signed integer. So integer, it means is a whole number, doesn't accept decimal. Indeed, if I write 0.00, for example, we have an error, because it's telling you, oh, we are now requiring the use of a double precision floating point number. So integer cannot be used anymore. So the data type that we're going to use in order to handle numbers with decimals will be double. Indeed, if now I hover over double, it's saying represent a double precision floating point number, which means it's gonna accept decimal places. So now what I need to do is to transform all my variables from integers that had limits as we have described into another data type that is double, which is allowing to have also both integer but also digital numbers. So this is more comprehensive data type that is more fit to purpose. So once again, we need to look everywhere where we use integer now and changing into double. Otherwise, we are gonna miss the digits if we don't say to the machine to parse our input number, which will have decimals. And so, yeah, let's change into double. Okay, let me go through the entire application to check. Here we go, even the results, we want it double. I could have a copy and find and substitute these values, but I think it's important that we do it one by one, because then we'll increase the learning outcomes. Okay, so let me save this application now and see if there are errors. We'll compile the application. There we go. So I will change also the text whole number, because now can just accept any number. So I will write now 23.56. Okay. The second number maybe 45.78. There we go. Is working. If we were not changing our variables from integer into the double data type, we will have had mistakes, and this would crash our application. Okay, so now just to make our application more beautiful, instead of all number, type the first number with decimal point. if you like, because now we know that is possible. Okay, because now our application is more powerful, isn't it? Okay, with decimal point. Second number. So of course also floating variables, in this case double as a data type, must have some limits, and we can actually check what are the limits of this kind of variable, but you see, it's doing the job. Now, as you can see, we have some, after the last decimal point, we have a 5, which doesn't really make sense to us. So we should actually round our number, maybe by keeping just 2 decimal places, which is more than enough, because otherwise this transformation of variable is retrieving a final minute outcome, this 5, 15, which is possibly incorrect. So we are going to round our output to 2 decimal places. Let's see how we can do that. Okay, to solve the issue, we need to round the output. So here, when we do the results, we can actually say this to the machine. Result sum it's equal, we can use this other operation, maths round and then we want to use the variable that is result sum, and then we want to specify how many decimals we want. I think we want the output as just 2 decimals, which is more than enough. Okay, let's run our application and see how it behaves. First number, let's put this number. Second number. Okay, now as you can see, the sum of the 2 numbers are rounded at 2 decimal places. Okay, that's the best possible outcome we can have for our application. Great.